today's video, we will be discussing November 2023 Tangent 2 Math AA Essay Paper 2. So question number 1 of the section A, as you can see, this is total mark of the 7 question, and this is from the topic 5 calculus section. Question A. So we have information first, so we need to consider the function defined by the f of x equals to x squared minus 8x. The graph of the f passes through the point A, which is the 3, negative 15. So question A, we need to find the gradient of the tangent to the graph of the f at the point A. So to solve this question, we need to find the gradient of the tangent line, right? So tangent line means that we have to differentiate the given function once. So when you differentiate the function f of x, we get f x equals to 2x minus 8. So to find the gradient of the tangent, we have to substitute the x value of the point A, which is the 3, into this first derivative to find the gradient of the tangent. So we do f derivative 3 equals to 2 times 3 minus 8. Then this gives us the value of the negative 2. And we can say that the gradient tangent is equals to negative 2. Then question II, hence we need to write down the gradient of the normal line to the graph of f at point A. So in order to solve this question, we already know that a normal line is perpendicular to tangent line. So means if this is normal line, then tangent line is like this, right? Or vice versa. So we can say this is our normal line, and the blue one is our tangent line. So we know that normal line is perpendicular to the tangent line. So means we can use m1 times m2 equals minus 1. Then if we say that m1 is the gradient of the tangent, then m2 is the gradient of the normal line. So we can do negative 2 times m2 equals minus 1. Then m2 is equals to 1 over 2. So we can say gradient of the normal line is equal to 1 over 2. Then question B, we need to write down the equation of the normal to the graph of f at point A. So to calculate the equation, or to identify the equation of the normal line, we need to use the normal line gradient, right? So we know that gradient is 1 over 2, and we're still going to use the point A, which is 3, negative 15, and we're going to use the linear line template equation form, which is the y minus y1 equals to m times x minus x1. Then we substitute all the values, then we get y minus 15 equals to 1 over 2 times x minus 3. Then expanding all this will give us y plus 15 equals to 1 over 2x minus 3 over 2. And means when you simplify this, we get y equals 1 over 2 x minus 16.5. Okay, then let's do question number 1C. So before attempting the question number 1C, we can see that there's extra information given, right? So we know that the normal to the graph of the f at point 8 intersects the graph of f again at the second point B. So means we are not sure how this graph looks like, but the coordinates of the B is actually the intersection point of these two graphs, right? And these two graphs are normal line and the function f. Okay. Then from question B, we do know that the normal line has the equation of y equals 1 over 2 x minus 16.5, and function f, its equation is f of x equals x squared minus 8x. Okay. There's several ways to solve this question, right? I mean, if you want to solve it manually, you can just set these two equations equal to each other and solve for the x and y. However, since this is a paper 2 question, you can simply use GDC to solve this, the values of the coordinates of the b. Okay. So what you can do is using GDC, you can go to y equals button, right? You can click the y equals button and go to this screen, and substitute your normal line equation as your first equation. So I will do 0.5 x minus 16.5 as my first equation. And for my second equation, I'm going to go, so x squared minus 8x. And I'm going to graph it. Okay, so let's try to find the intersection point. So my first intersection point is right here. So my first intersection point is 0.1 and negative 14.99. My second intersection point is about 5.48, comma negative 13.75. Okay. So you can see that this is point A, right? So this is point B. So since we are trying to find the coordinates of the point B, your answer will be 5.48, comma negative 13.8. Okay, then let's try the question number 2. This is 6-point question. The following diagram shows a pyramid with a vertex V and rectangular base OABC, and point B has coordinates of the 6, 8, 0, and point C has the coordinates 6, 0, 0, and point B has the coordinates 3, 4, 9. So question A, we need to find the length of the length between the point B and V. So means we are trying to find this length here. So we know that there's 2 points, which is the 6, 8, 0, and V has a coordinates of the 3, 4, 9. So we're going to use the distance formula. So question A, so using distance formula from your formula booklet, we're going to do D equals square root x squared minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Then we can do 6 minus 3 squared plus 8 minus 4 squared plus 0 minus 9 squared. Then we can do 3 squared plus 4 squared plus minus 9 squared. Then this gives us the value of square root 106. And this is approximately 10.2956. So we can say that the distance between the point B and V is equals to 10.3. Then question B, we need to find the size of the angle B, V, and C. So we need to find the angle V, right? So when you look at this diagram, what we are trying to find is this angle here. We are trying to find this angle. And you can see that the lengths between the C and V, the lengths between V and V are actually same, because this side actually creates the equilateral triangle. So we can say this is about 10.3 10.2956. This side is also about 10.2956. Then to find this angle here, since we're going to use one of the cosine rule or sine rule, we have to figure out the length between the C and the V. Okay, so what you're going to do is, let's redraw this triangle like this. Okay, then we can say that, okay, so this side and this side is same, and both of them has the length of 10.2956, 10.2956, and we need to find the length between this point C and the V. Okay, and the B has coordinates of the 6, 8, 0, and C has coordinates of the 6, 0, 0. Okay, then we know that right away the length between the point C and B is 8, right? Then I'm going to use the cosine rule for this case. We can do B squared equals to A squared plus C squared minus 2AB times cosine V, and C. Then we can do A squared, since I'm calling this as V. Okay, this is A, this is C. A squared equals to 10.2956 squared plus 10.2956 squared minus 2 times 10.2956 times 10.2956 times cosine angle V, and C. Then we can solve for this angle. Then this gives us the value of the BBC is equals to 0.798037, right? Then we can say that the angle V is same as 0.798.